So now we need to switch gears here and talk about isomers. So it is possible for the same atoms to be arranged in different ways. And so isomers are compounds with the same chemical formula but different molecular structures. So an example is acetic acid versus methyl formate. Both have molecular formula of C2H4O2, but they have different structures and properties. So if we look at the structural formula for acetic acid, we have more detail than just molecular formula. We can see which atoms are bonded together through covalent bonds. And so here we can see that we have carbon covalently bonded to 3 hydrogen atoms, and then it's also bonded to another carbon atom, which is doubly bonded to oxygen and also singly bonded to oxygen. And we have hydrogen here. So here we have this C double bond OOH. This is called a carboxylate formal group, and it is different from another structure here, methyl formate. So you can see instead of the carbon-carbon single bond here, we have a carbon-oxygen single bond and then an oxygen-carbon single bond here, which is basically forming an ether structure here. And so these are two completely different types of compounds that have the same chemical formula. And so they're referred to as isomers of one another. So we can also see that here we have two examples of two molecules of carbone. So they're spatial isomers of one another. They are different relative to the orientation. And so one smells like caraway and the other smells like spearmint, so they have different properties as well. There are stories out there before scientists knew about isomers where drugs were given and there was a mixture of isomers, and it's important in biology that the structure, chemical structure of a compound, this 3D structure is very important. Our proteins in our cells are very specific to certain structures, and so sometimes a structure will fit perfectly. If you have an isomer, it's the same structure, but it's structured differently because it's an isomer and it's not the same thing, then it can bind or not bind at all, or cause adverse effects like killing the patient. So there are stories out there where mixtures of isomers occurred during the chemical process of creating drugs and ended up killing people due to basically really bad quality control. Nowadays, of course, we have quality control where we make sure that everything we synthesize has a certain chemical composition, etc. But back then they didn't know about it, and it caused problems. So the next thing we're going to talk about is the periodic table and how it's organized, and who came up with this idea of the periodic table, who made it. Right? The periodic table is a man-made table that organizes naturally found elements and also synthetically made elements. And so we're going to talk about that. We're going to talk about how it's organized. We talk about metals and metalloids and nonmetals and their properties and location on the periodic table. So Dmitry Mendeleev is the one who is credited for creating this idea, or coming up with this idea of this table, this organization sheet called periodic table. And Meyer also was credited somewhat with its development. And so they recognized that there was a periodic relationship among the properties of the elements known at that time. So for example, lithium, sodium, and potassium are all shiny. They conduct heat and electricity very well, and they all have similar chemical properties. Calcium, strontium, and barium, they are also shiny. They can conduct heat and electricity well, but they are less reactive than lithium, sodium, and potassium. So Mendeleev and Meyer published tables with the elements arranged according to increasing atomic mass. Mendeleev used his table to predict the existence of elements that would have the properties similar to aluminum and silicon, but were not yet known. So they basically filled in the table and were able to predict elements that had not been found yet based off their location on the periodic table. The discoveries of gallium and germanium provided great support for Mendeleev's work. So here's a picture of Mendeleev and his periodic table. You can see how it's organized based off atomic mass. So by the 20th century, it became apparent that the periodic relationships involved in atomic numbers rather than atomic masses were evident. So this came about the periodic law, which is a property of the elements are periodic functions of their atomic numbers. So that means we can look at the periodic table and be able to predict certain things about an element based off its location on the periodic table. So modern periodic tables arrange the elements with increasing order of their atomic numbers and their groups atoms with similar properties in the same vertical column. So vertical columns are called groups. Okay, they're numbered 1 through 18. Periods or series are horizontal rows. Okay, so let's look at a periodic table. So let's go with the horizontal rows first. So there are 7 horizontal rows, 1 through 7. These are referred to as series or rows on a periodic table. So also referred to as periods. That's probably the most common word that I use, periods or series. And then you have groups that are organized horizontally in a column here. I'm sorry, vertically in a column. And so there are 18 of those, and so 1 through 18. Now I wanted to show you a different periodic table because depending on the periodic table you're using, it can look different. So numbering the groups from 1 to 18 is sort of like what they do nowadays, so like a more recent periodic table. But when I was in undergrad, we also used a different numbering system. So this periodic table shows you both types. So here you have the 1 through 18 like you have and saw before. And then below that you have Roman numeral 1A, 2A, and then it's written out 1A, 2A. All right, so anyways, the Roman numerals basically distinguish 2 different sets of elements on the periodic table. The A elements, these are referred to as representative elements, okay, and the B elements here. All right, so you have 1A, 2A, if you skip the middle, 3A, 4A, 5A, 6A, 7A, 8A, and then you have 3B, 4B, 5B, basically starts here, 1, 2, 3, all the way to 10. Well, it's 8 3 times, but there are 10 vertical columns there. These are referred to as the transition metals. We'll talk about that later. But anyways, I wanted to show you the 2 different types of labeling when you talk about periods on the periodic table. All right. So, groups on the periodic table. All right. So, this is important because most of the time when we're talking about like determining oxidation numbers, we're going to be talking about the representative elements or the A-type elements. Okay. So the B-type elements, their oxidation numbers are harder to predict, and we're going to talk about a little bit about that later. But it's important to be able to know what those numbers mean. They pretty much mean the same thing, except it's sort of organized a little bit better than just naming them 1 through 18. Okay, so periods are the rows, and then groups are the columns. And so the the group names are also, we're going to learn the family names. Okay, and so we said earlier that, Mendeleev, he organized the periodic table based off the masses. Nowadays, the periodic table is organized based off atomic numbers. Okay, increasing atomic number, and the elements in a certain group act similarly, they react similarly, they look similarly, so they have similar properties. And so we're going to talk about that, and this isn't going away. This is sort of just introductory information about the periodic table. There's so much information here that you can use. So another thing we can look at here are the 3 different types of elements on the periodic table, and that those types are the metals. They're shiny. We know what shiny means. Malleable means that the metal is, you're able to hammer it into a thin sheet. They are good conductors of heat and electricity. Okay, we know that. We know that we use copper or gold or platinum for wire. And because, why? Because metals are good conductors of electricity. And they also are good conductors of heat. That's why we use metals for making pots and pans. Nonmetals appear dull. They're poor conductors of heat and electricity, so they pretty much have the properties that are opposite of that of metals. And then the metalloids conduct heat and electricity sort of well, better than nonmetals, but not as good as metals. And they possess some properties of metals and some properties of nonmetals. So they're sort of like in between metals and nonmetals. So we have 18 different groups. The main group elements are representative elements, which I pointed out earlier, groups 1 and 2 and 13 through 18. The transition metals are groups 3 through 13, so let me bring that back here. So 3 here through, let me see here, 3 through 13, which may not be the case. 3 through 13. All right, so here transition metals are 3 through 13. So here we have some transition metals too. And then inner transition metals are the 2 rows at the bottom, the lanthanide and actinide series. So that's what you see here, lanthanide and actinide series. These are also considered the inner transition metals. All right, so let me go back here to talking about inner transition metals, because here we can see if you follow the atomic number, so you start out with 1, and then there's 2, and then 3 and 4, and you keep going from left to right, right? 11, 12, 13 through 18, right? We keep going down. Okay, we keep going down. All right, 55. Okay, so 55, 56. And then it says 57 to 71. So 57 starts here. Okay. So the lanthanide here, it's the first one. So 56, and then it goes to 57 all the way to 71. Okay. And then picks up here 72 all the way to 85, then 86, and then 87, 88, and then 89 through 103 is the actinide series here. Okay, and then all the way to 103, and then it goes back here to 104 and 105, and then all the way to 118. All right, so I wanted to just show you where the lanthanide and actinide series fits into the periodic table. All right, so we're going to talk about family names, okay? So you have different group numbers, and we talked about the lanthanide and actinide series here. Some groups have family names, okay? So the first group here is called the alkali metals. Then group 2 is the alkaline earth metals. Now this is important because I could ask you a question like sodium is a